Hi guys, welcome back. Before we start today's lesson, I would like you to kind of quiz yourself on yesterday's lesson. So hit pause and do these 4 problems. Treat this like a little mini quiz, and then the answers are on the next page and I'll go over them with you. So hit pause and do these now. Okay, so here are the answers to the first two. And how do you get those answers? Again, if you're trying to find the midpoint, just get the point in the middle. Okay, so for the first one, add your 2 x's. 5 plus 3 is 8, and divide by 2. That's where that 4 comes from. Then do the same thing with the y's. -2 plus 8 is 6. Divide by 2 and you get 3. Double check just to make sure that 3 really is in the middle of -2 and 8 on the number line. Okay? Okay, number 2, add up -1 plus 6, which is 5. And 5 divided by 2 is just 5 over 2. Or you could have said 2.5, same thing. Okay, but get used to the fractions. Then add up the y coordinates. -5 plus -9 is -14. Divide by 2, and that's where the -7 comes from. Okay, the next 2 problems. Okay, if I give you the midpoint, you just need to make sure that this point really is in the middle. Okay, so to do that, I think to myself, to get from -1 to 5, that's right 4 on the number line. Add 4. So I want to add 4 more on the number line. Okay, well 5 plus 4 more would give me that 9 right there. Okay, looking at the y coordinates, to get from -3 to -6 on the number line, I have to go left 3. That's subtracting 3. So go left 3 more, subtract 3 from -6, and that's where that -9 comes from. Okay? All right. Number 4, when you switch from a negative to a positive, kind of visualize going past 0. So on the number line, to get from -2 to 4, I have to go past 0. So -2 to 0, and then 0 to 4. So that's right 6. So go right 6 more. 4 plus 6 gives me that 10. Okay? And then the y coordinates, to go from 5 to -3, I had to go left 8. So I'm going to go left 8 more, and you get -11. All right, today's lesson, hope you guys got 100 on your quiz. It doesn't get any harder than that, by the way, so hopefully you're doing well. All right, today's lesson, just like yesterday, I'm going to kind of sort of show this, not so much derive the formula, but make sense of the formula. Okay, so I'm going to show it to you graphically, which takes a little longer, but I'll show the graph first so that you can see why it makes sense. And I kind of want you to remember that you can always graph things when you get stuck and figure them out some other way if you forget the formula. All right, so we want to find the length of segment AB. Yes, in the future, you should know that's just find the distance from A to B. You should know that. But let's say you forget. Well, you can always figure it out another way. And for this one, the distance formula, you can always use the Pythagorean theorem. Okay? Turn this line segment into a right triangle. So, okay? If we turn it into a right triangle, then I can use the Pythagorean theorem to find this missing length that I'm trying to find. Okay? And since I used graph paper, I can figure out what these lengths are. This length here went from 1 to 4, so that was a 3. I can count the squares. This length going up and down went from 2 to 6, but I could count the squares. And now I can find the missing length using the Pythagorean theorem. A squared plus b squared is equal to c squared, where c is what I'm trying to find. Okay, 3 squared is 9, 4 squared is 16. Add those up, you get 25. Take the square root of both sides, and c is 5. So the length of AB, the answer to the question, that length is 5. Okay, now I'm going to do the same problem using the distance formula, and you're going to see that the distance formula actually is the Pythagorean theorem. Okay? So using the distance formula, this is the distance formula right here, it says the distance from A to B will be the square root of. This says subtract your two x's, so that would be 4 minus 1, and square it, plus subtract your two y's, 6 minus 2, and square it. Okay, I know this is sloppy, it's because I'm using the worst pen in the world for this. So now 4 minus 1 is 3, and I have a 3 squared. 6 minus 2 is 4, and I have a 4 squared. Next I would add them up, and you'd get a 9 and a 16. Add those together, and you get the square root of 25, which is 5. Of course we got the same answer. But can you also see that we got the same numbers? I wish I had a bigger board space to show you so I could have left the other stuff up there. But this 3, where did that 3 come from? That was literally the distance we went over. Because it is how you get the difference of the x's is how far you went over. This 4 was how far we went up and down, 6 minus 2. And what did we do within the Pythagorean theorem? A squared plus b squared equaled c squared. Well, guess what we ended up doing over here? We squared them. There they are, 9 and 16. Then we had to add them up. Yep, we did that. And then you do the square root to get c by itself. Yep, we did that. The distance formula is basically just doing the Pythagorean theorem for you without you having to graph it every time. So I want you to try to remember that. You can always use the Pythagorean theorem. You just have to draw a right triangle out of that line segment. Okay? So it's the difference of the x's, the difference of the y's. Okay? You're squaring each of them because it's the Pythagorean theorem. It's the same as a squared plus b squared equals c squared. Try to remember that. It's the same as a squared plus b squared equals c squared. And that's why this formula has a plus sign in it. So let's just apply that formula now without having to graph. All right? So the distance between these points would be, okay, this says subtract the second point and then the first point. It honestly doesn't matter which direction you subtract because when you square a number, it's always positive anyway. So I'm going to subtract my x's. I can either do 5 minus negative 3 or negative 3 minus 5. It honestly doesn't matter. But if I'm going to go legit by what the formula says, I'll do negative 3 minus 5. And then you're going to square it. Plus, because it's really a squared plus b squared, same as the Pythagorean theorem, plus, subtract your y's, negative 2 minus negative 4, or negative 4 minus negative 2. It doesn't actually matter. Negative 4 minus negative 2. And you've got to remember to square it. Now this two negatives right here, people forget that minus a negative. So make sure you always write minus inside parentheses, but a plus in between. There's always a minus in between. Okay? All right, now simplify that. Negative 3 minus 5 would be negative 8. Take that negative 8 and square it. When you square a number, it always ends up being positive. So this is negative 8 times another negative 8, which is going to be a positive 64. Don't rely on your calculators, because if you put negative 8 squared into your calculator, it's going to give you the wrong answer. That would give you a negative 64. And it's because it's implied it's negative 8 times negative 8. So just remember, when you square something, this number will always be positive. Okay, plus, this is negative 4. Two negatives here make a big fat plus. So that's negative 4 plus 2. And negative 4 plus 2 is negative 2. Negative 2 squared is negative 2 times a negative 2, which is positive 4. Add those up, and we get the square root of 68. They said to write this rounded to the nearest tenth, so now you put it into your calculator, the square root of 68. I have to get my calculator, so one moment, please. So as a decimal rounded to the nearest tenth, that would be approximately 8.2. Now, if they said simplified radical form, then we would have broken down that square root of 68 differently, but I think we'll do that tomorrow. Okay, so next problem, I think, nope, I guess you only need one. Doesn't seem like we need more than that anyway. So good luck with your assignment today. The assignment today will do the distance formula and it'll also review the midpoint formula from yesterday. You might want to start with the distance formula problems, which I think are at the bottom of the worksheet, but whatever, it's up to you. Good luck. See you next time.